Right here, we're asking to solving this linear program using a graphical solution procedure. And I did explain to you that in the future weeks, you're not going to be asked to calculate each corner point in the optimal solution by hand and graphing everything. The only reason why I'm showing you how to do all this is that we're going to be using Solver, and I need you to understand why the solver gives you uh, that optimal solution. Where do the numbers come from? And that's what you would think as learning, because you need to learn the process in order to analyze the results. If I just give you the result, it's just the same thing as your homework. If you just give me the results but no calculations, how am I gonna know that you actually understood the process? So right here we have a linear programming to maximize this objective function subject to these constraints. And we have learned right here that uh, for A, which they don't define what is A and B on the problem, so you can think of anything, as I believe I mentioned before, for example, your two favorite foods. So let's say that a, it's protein, and B, or let's say a piece of meat, and B would be carbs. So it says that for your protein, you want to have less or equals to 100 grams of protein. And for B, which is carbs, you want to have less or equals than 80 grams of carbs. And then it's saying that if I do 2 times my protein plus 4 times my carbs, everything has to be less or equal than 400 grams of carbs, for example. It's just to make it these numbers a little more, give a little more meaning for these values. Okay, so right here, let's, and also note that usually we have X and Y. However, the variables can be named as A and B, or they can be named as X1, X2, Y1, Y2. Really doesn't matter. Here they decide to use A and B. So let's go ahead and create a little table for A and B. And the reason why I'm doing that, so I can set up, this should be long enough. So I can set up a little table where I set one value to, for example, if I set B to 0, what would be the value for A? If I set A to 0, what is going to be the value for B, and so far and so on. So first of all, on your graph, you're going to have the origin. That means where the values meet, which would be when A is 0 and B is 0. Okay, so for the first values, you're always going to start with the values as 0 and 0, which is, if you had a graph right here, the little, let me, I just want to put the lines, not the graph itself. So let's suppose you have a graph over here, and insert another one right here. So your origin right here, this point right here, is always going to be 0 and 0, where they meet. Okay, so this is for X, this for Y, or this is for A, and this is for B. But this little point right here is always going to be 0 and 0. Okay, so I just want to explain these 2 points. Now, we have right here the A. Well, if you set up as an equation, and you would have, for example, A plus B, you know that A, you have the A value, you don't have anything for B, correct? And then is equals to 100. Therefore, if there's nothing, so your value for A is equals to 100, correct? So right here, if A is 100 and we don't have anything for B. The same thing is going to happen on the second constraint, where it says that B, if you put in a equation format, B is equals 80. In this case, if B is equals 80 for this equation, we don't have A. Okay, so now there's 2 more points. Um, well, we know that A is equals 100 and we know that B is equals 80. So what we can do, we can actually substitute the value for A right here and solve for that. And then right here we can substitute B and then solve for A. Okay, so that's what I'm gonna do for this last 2 points. And the reason why I put it these last 2 points exactly for that. I'm going to solve for A here and I'm going to solve for B and see what values we have. So let's go ahead and I'll just put it over here. 2A plus 4B is equals, I'm putting an equation format, okay, is equals to 400. Make it this smaller. We don't need it so big. Okay, so if I'm telling you, oh, now our little table disappear. So let's move it over here. I want you to see the table. Okay, so now if I'm telling you that I have this value right here, A is 100. So let's go ahead and do 2 times 100 and let's solve for B plus 4B is equals to 400, correct? So 2 times 100 is 200, or you can just do 2 times 100. 200 plus 4b is equals to 400. Okay, now let's subtract 200 from both sides. Therefore, you're going to have 4b is equals to 400 minus 200, correct? It's 200. Now let's divide both sides by 4. So b is equals to 200 divided by 4, which is 50. Therefore, when a is 100, the value for b is 50. Okay, that's another point on my graph that I'm going to be graphing for you. So now we're going to do the same thing. However, I'm going to use the value for b. So now we have 2a, the same thing, plus 4b equals 400. So let's solve now for a. So 2a plus, and then we have 4 times 80. I'm using this constraint right here, is equals 400. So 2a plus, and then you do, so it's 320 times 80 is 320 is equals 400. Now you have 2a plus, actually you're subtracting 300 from both sides. So you're gonna do 400 minus 320. And lastly, you're gonna do the a divided both sides by 2. A is equals the 80 divided by 2. Okay, so now we know that when B is set to 0, I'm sorry, to 80, A is going to be 40. Okay, so let's go ahead and graph that so you can see how it looks. The way I do it, let me just set this 2 over here in graph then, which is really not going to present me any lines. I just want to get the shell of the graph. Okay, I really want to make it a bigger graph, so I'm gonna make this smaller. Hopefully you still can see it. I want to make this graph bigger enough like this, a little more maybe. Now what I want to do, I want to select the data. I actually want to switch everything around. I'm gonna delete this first one here because it didn't put the way I wanted. So let me remove it. And I'm gonna add now one by one. For my X, I'm not worried about the title here. I'm worried about my points, my optimal value, and what is outside my feasible area, what is inside my feasible area. So for X, it's 0, or for Y, which is the same as A and B, is also 0, and you do OK. And then right there, there's your first point right there. Now we're going to add the second one. For X or A, you have 100. For the second one, for X or A, you have 100. And you add, and that's your second point right there, which tells you that when B is 0, A is 100. Let's add a third one now. When A0, B is 80. Okay. And adds the point right there. When A0, B is 80. Let's add one more. Well, we have when A is 100, B is 50. Do okay. Let me move it over here. There is the point over here. And then let's add the last one. When my A is 40, my B is 80. And okay, okay, and okay. If you notice now, we actually have 5 points. Maybe I can try to move this and make the view bigger. Make this view a little bigger. Okay, so hopefully you can see it better like this. Just one and up. Okay, so now as you can see, we have 5 points right here. Okay, the first one, let's start with the first one. 0, 0 right here. And then for 100 and 0, correct? Then we have 0 and 80. Actually, this is wrong. It should say 0 and 80. Let me go over here, go to Format, actually Design, select Data. I'm not sure which series is that. The third one? Edit. Oh, I don't have one. See, it sounds interesting that I actually like sometimes when I get some errors so you can see how to fix it. See how I did not actually click the 0, so you just put a 1 for me. I have to click 0 over here, and now it's showing 0. Okay. So now if I go back to my graph, it should show me 0 and 80. Perfect. Great. Okay. And then we have the fourth point right here, which is when A is 100, correct? So 100 right here, you go up. And then my B is 50, meets right here. And then last we have 40. When A is 40, so 40 is right here, go up. And my B is 80, and they meet right there. That's my point. Okay. So now we're going to define your feasible solution. That means, for example, if my feasible solution right here is telling you everything less or equals to, therefore, everything to the inside, so less or equal than these points, that they're gonna point to your origin right here. If I have values of higher or equal, it's higher than what you define as the point. You'd go outside this, and the outside will be the feasible area, right? The feasible region. Right now we have everything less equal, so we know that this area right here inside, which I'm gonna shade it for you, is the feasible region. That means any point in here should provide you a feasible solution. So let's go ahead and insert. Let's go to Format, and let's insert now the lines. I wonder if I do the free form, then I don't have to go to all this trouble. So I'm gonna click the right button here and let it go. Look, see how you can see the line? Then I go all the way to 80. I'm gonna click the right button. Oh, maybe a little more. I'm gonna click the right button again and let it go. Oh yeah, I can do it much better. Then I'm gonna click the right button again and let it go. Then I'm gonna click the right button again, let it go. And then I'm gonna click the right button again and let it go. And now it's gonna connect and it's gonna give my shaded areas. So see, it's much easier than I showed you before. Instead of doing the lines and then doing the shaded area, you can just go ahead and use the free form, and it already gives, and then you do the last click. So right here, this is telling you that this is your feasible region. Any point in here, it's your feasible region. Once you have reached anything outside, then it's not your feasible region. So now we need to figure out of these 5 points, because we have 1, 2, 3, 4, 5 points, which one provides me my optimal solution. That means if I'm maximizing this objective function, I'm looking for the higher value. It could be in dollars or whatever it is the problem trying to maximize profit, asset allocation, whatever it works to maximize. Well, how can we do that? Well, really, your textbook mentions to you, I don't know if it's in a two, section 2.2 or 2.3, it mentions that it really doesn't matter what method you choose to graph your chart. It could be by hand, it could be like this, Excel, it could be anything, and you're gonna see that it still presents you a difference on your values. So the best thing that you can do to learn which point of this five provides you the optimal solution is by solving this equation by using substituting A and B for each. So all we have to do, we do need to evaluate each one. So we're gonna do equals to, and I'm gonna use this objective function right here, 5 times this A plus 5 times this B. Okay. Well, if you do 5 times 0 is 0 plus 5 times 0 is 0, 0 plus 0 is 0, so you should get a 0. And here's your value. Okay, so now all I'm gonna do is to drag it down because Excel is gonna update for values for A, for B, value for A, for B, and so far and so on. Therefore, the second one is gonna do 5 times 100 plus 5 times 0. 5 times 100 is 500 plus 5 times 0 is 0. So 500 plus 0 is 500, so it should give you 500. For the third one, for A is 0, for B is 80. Therefore, 5 times 0 is 0 plus 5 times 80 is 400. Therefore, 0 plus 400. Wait, no move. Drag it down. Don't do like me. Okay, now we're going to have 100 for A, 50 for B, 5 times 100, 500. 5 times 50, 250. 500 plus 250 should be 750. So far is our highest value. Okay. And this is the lowest value. And then the second lowest value. And now we're going to do 5 times A, or 5 times 40 is 200. Plus 5 times 80 is 400. Therefore, 200 plus 400 should be 600. There you go. Therefore, just by looking here, you know this value is the maximum. Let's suppose that you had so many values, so all you have to do is to ask for the max of these values. There you go. So it's 750. Therefore, your optimal solution is 750, and the points that have provided the optimal solution was actually over here, or 150. And that would be then for this problem. You have you have um, calculated all the values, all the possible points. You have graphed them. You have shaded your and you have located your feasible region, and you have also found what is your optimal solution. Therefore, if you would, for example, be asked by your manager to tell him what would be, I want to, allocate these assets, how many of A I should use, and how many of B I should use. Then you would tell him, well, you need 100 of A and you need 50 of B to get the maximum, the optimal solution of 750. So you're optimizing these values. And then you look at all this, and like I said, we are not going to be, I mean, I find it this all very interesting, but there is a much easier way, which is by using solver, which means when you plug all the values in solver, it should, let's say, give you exactly the same results that this objective function maximizing subject to this constraints, it should tell you that you should get 100 of product A, with which whatever that is, and 50 of product B to get a maximum value of 750. Okay, so how we do that? Let's go ahead and let me just hide this. However, I have, you know what? I have placed it before. So let me just put it all. Here you go. I just don't want you to get confused with all this. So I can either hide it or I can delete it. Let me see what else was here. I'm gonna get rid of the graph. Okay, now you saw it. And I'm gonna move this back here. And then if you look at all this and you wonder what in the world is this? Well, that's why we're gonna work on it. And again, let me remove this part because I really don't want to confuse you. So what does this mean? Remember, we are trying to maximize this objective function based on product A, whatever that is, plus product B to get my optimal solution, correct? Therefore, I have put here product A. We don't have the result because that's what a solver is going to do for us. And then product B, it should give me, remember that we just calculate on that little table 5 times whatever is product A plus 5 times whatever is the best for product B to give me the optimal solution. Right here, we know we have 1, 2, 3 constraints, correct? You could say that this is a for constraints telling you that all values have to be uh, higher or equal. So that means no negative values. But I'm going to show you that in solver as well. Well, on your right hand side, those are set. You cannot modify that right here. Therefore, I just put your right hand side, I repeat these values. For your sign, same thing. They're set. We're going to be defining that in solver. The important thing is over here. So all, if you look to the formula, all I did was that it's saying that A, 1A, therefore this value has to be equals to your product A. Whatever it is going to be 1 times that value. Okay? Remember we did the little table to get those values? On the second constraint, we have B, and it's saying 1 times B. So 1 times whatever I find it over here goes over here. Okay. And then lastly, I have the whole formula for this constraint, which is 2 times whatever we find here plus 4 times whatever we find here. It's going to give us this value over here. Okay. So if you do not have solver, which is under data in Excel, you need to go to file, at least in my version of Excel, go to options and go to add-ins. Right here, you should have the option of solver, and also there's the data analysis. I already have solver, so I don't need to re-add it. Once you have make your selection, make sure you do go and then okay. If you just do okay, it's not going to do anything for you. Okay, and then there is solver. So when you have all this set, let's click solver, which I have worked on it before. I'm gonna delete it so I can explain. And actually, I did a shortcut, but I wanna explain one by one for you. So this is what you're gonna see solver. So, and then you're gonna set your parameters. If you remember, one of the steps is to figure your parameters. These are your parameters. We need to set the objective. What is my objective function? My objective function is right here on this cell. Remember, in this cell, if you do look at the formula for the cell, it shows this objective function, which is 5 times A plus 5 times B. So that's my objective. And I want to do what? I want to maximize. This is very important on your final exam. If I ask you for a minimization problem, you must change this choice. Otherwise, you leave it at maximization. We're not going to be using value of. By changing what cells. Remember, I'm trying to define which point is better. So we're gonna always be changing these two cells right here for product A and product B, which is the same as our little table that we calculated before. So if A is 0 and B is 0, then right here is going to be 0, remember? And if A is 100 and product B is 0, remember we did that before? It would be 5 times A plus 0 would be 500 over here. So we're actually changing this to cells. So all you need to do is to click right here, and then it lets you select the information. So I want to change this to cells to find this value. Okay. Now subject to the constraints. Well, you have three constraints, remember? So let's click in add to add the first constraint. The way I do it, I just select all of them, do the sign if it's the same sign, and then select all of them and it's the same thing. But I'm gonna do one by one so you can see what I'm doing. So we're gonna reference to the left hand side. This is the same as the left hand side right here. Just think as this is A and this is B. And then you have the equality sign between. So, and it is less or equal, so we left that. See, we have other options. And then subject to no more than 100, correct? So that's cell. Then we're gonna add a second one. Click here. We're gonna do that A is less or right? Is that what we or this side? No, I shouldn't say A actually. Whatever equation is on this side, less or equals than the value that is set for you. And the reason is because right here you see you don't have only A or B, you have a full equation. So really the left hand side is the full equation. And then one more, we're gonna reference to the last one, which is the left hand side or this equation right here, less or equals to 400. Okay, and you do okay. So now we have that. We want to set this objective right here where my formula has been inserted before by changing these two values and subject to these constraints where B, column B are my equations, then the equality sign in my column D, those are my values that they're constrained to. Okay. Right here, see how it says make unconstrained variables non-negative? Well, you could actually go ahead and either include another one here, but I don't want to confuse you, which is right here saying everything has to be higher or equals than 0. Another thing we always going to be using this class simplex LP. We're not going to be using the other two. So please make sure simplex LP is chosen here and you're going to do OK. Watch what happens over here. I'm going to click OK and watch what happens on all these values that I have set that we need to modify this to get the maximum value, the optimal solution, and then also how much of each constraint. So watch that left side. See how it changed? You're going to get this message right here. Solver found a solution if we do everything right. All constraints are in optimality conditions are satisfied. That means it found me a solution, how much of A, how much of B, my optimal value by respecting all these constraints. What you also can do, because we're going to be addressing this in the future weeks, but I'm not going to be explaining right now, is to actually choose the reports. When you do OK, you're going to notice down here, it actually adds three reports for you. And if you look at the report, it tells you we need 100 of product A, 100 product B to get a value of 750. And right here, same thing. We need 100 product A, 50 of product B to get 750. And then you can see the constraints that I haven't put it for us. And again, 100 a product A, 50 a product B to get 750, which we're going to be addressing later on, not right now. So let me move problem B over here. Okay. So do these values look familiar? I don't know if I deleted the whole thing. No, I actually didn't, which is wonderful. Remember I said that to get my optimal solution, I need these points over here. I need A to be 100. I need B to be 50 to get me a maximum value of 750. Therefore, Excel has calculated with solver for us the same thing, and it's telling you actually is going to use the full value for A, the full value for, no, actually less or equal, so you only use 50 of B, sorry about that. And then right here, the values when 2 times 100 plus 4 times B100 should be less or equals than 400 is actually use the whole amount. And we would be done with problem 11.